In this video, we'll look at the calculation of portfolio convexity when we are given the Macaulay duration, the dispersion, and the cash flow yield. So we have a portfolio of annual pay bonds with a Macaulay duration of 7.2 years, a dispersion of 1.8 years squared, and an annual cash flow yield of 4.6%. Calculate the portfolio's annualized convexity. So we'll have to use this formula where we'll take the Macaulay duration squared plus Macaulay duration plus dispersion, and we'll divide by 1 plus the cash flow yield squared. Now, we'll substitute the values directly. So that will be 7.2 squared plus 7.2 plus 1.8. Then we divide by 1 plus 0.046 power 2. Then we'll get 55.61 years squared. Okay, so convexity is a second order effect, so the units is squared. So this is already annualized, so there's nothing further for us to do. Now, in the next example, what if the portfolio consists of semi-annual pay bonds? So we have the Macaulay duration, say is 15.4 semi-annual periods. The dispersion is 2.6 semi-annual periods squared, and the annual cash flow yield is 5.1%. Calculate the portfolio's annualized convexity. Now with the same formula, we will substitute the values as it is. Okay, we don't convert the Macaulay duration to years. Okay, we leave it in its original units. So we'll have 15.4 squared plus 15.4 plus 2.6. Then we divide by 1 plus the cash flow yield per period. So since it's a semi-annual pay bond and the yield is in annual terms, is per annum, so we need to take 5.1% divide by 2. So that gives us the yield per semi-annual period, and then we will square the denominator and we'll get 242.628193 semi-annual period squared. So you can see that the convexity retains the same unit, which is semi-annual periods, and is squared because it's a second order effect. Now to get the annualized convexity, okay, we have to divide by 2 squared. We divide by 2 because we are going from semi-annual period to annual period. So that is 1 year with there's 2 semi-annual periods, so we divide by 2. But the squared here, the power 2 here is because convexity is a second order effect, so we need to include that squared. And we'll get 60.66 years squared. Okay, so that's the annualized portfolio convexity. In another example, what if the portfolio consists of quarterly pay bonds and the Macaulay duration is 31.5 quarters, the dispersion is 3.7 quarters squared, and the annual cash flow yield is 4%. So using the formula, we will substitute the numbers again as it is in quarters because it's quarterly pay bonds. So we'll have 31.5 squared plus 31.5 plus 3.7. Then we'll divide by 1 plus the cash flow yield per quarter, which is 4% per year, divide by 4 quarters. So that's 1% per quarter. And then we square it. Then you will get 1007.0205176 quarters squared. And then to analyze it, we divide by 4 squared. Okay, 4 because in 1 year there are 4 quarters, squared because convexity is a second order effect, and we'll get 62.95 years squared for the annualized